The ChatGPT moment for robotics may be right around the corner.
Is that an army of robots?
It is unlikely that you'll write Python code.
Oh, I hope my programming job is safe. Let's get into it. It's a 2-hour keynote packed with new technologies. And what Jensen Huang covers is NVIDIA's 5 pieces to the new industrial revolution. And each of these pieces is meaningful and magnificent in its own way, and then even more revolutionary altogether. We got new software, new hardware, new robots, and new ways of working. So it's a beast of a presentation that he has today. I'm a machine learning engineer myself based in Silicon Valley, so I'll be breaking down the keynote with my technical perspective while cutting through the marketing fluff. I watched the keynote a couple of times to make sure that I could share with you the true magnitude of what NVIDIA had to share today. And I'm wearing my NVIDIA colored shirt, so nothing's getting past me. First is the new industry that has evolved. In the past decade, starting in 2012 with AlexNet with billions of parameters, to nowadays with GPTs with trillions of parameters, the training compute in flops has had to match that growth. So we've moved from AI to generative AI, made possible by accelerated computing. And this is projected to be a multi-trillion-dollar industry. So this sets the stage of what NVIDIA has prepared for us today. Now for the star of the show, computing power and GPUs, the thing that NVIDIA is most known for nowadays. So I'll be giving this the biggest chunk of time simply because there are so many details to emphasize in it. Blackwell is their newest chip. 2 of them unified together into one Blackwell GPU. Jensen compares the Blackwell GPU chip to the Hopper GPU chip, revealed 2 years ago, also at GTC.
Very big GPU.
He's like, yeah, that's some big GPU energy. But alas, we are not getting rid of Hopper just yet.
Oh, good girl.
Hopper is still being used with 2 Blackwells to form one super chip. That costs how much?
This right here is $10 billion.
Okay, yeah, cool. 2 of these super chips go into a computer node, and then 18 of these computer trays go into a rack called the GB200 NVL72, which brings us to a total of 72 Blackwell GPUs, hence the number 72 here. All these GPUs are connected together with the latest NVLink system, which allows all the GPUs to act together as one giant GPU. You can see the 5,000 NVLink cables running here, supporting 130 terabytes per second of bandwidth, which Jensen claims to be a larger bandwidth than the entire internet service providers, all in one of his racks.
So we could basically send everything to everybody within a second.
Using the NVLink switch chips and cables also replaces the need to use optics and transceivers, thus a savings of 20,000 watts in energy used compared to the usual 120,000 watts used.
We drive down the cost and the energy, they're directly proportional to each other, cost and energy associated with the computing so that we can continue to expand and scale up the computation that we have to do to train the next generation models.
This single rack is able to train at a speed of 720 petaflops, which is a 22 times speed up compared to the previous version.
Now this system is kind of insane.
Just to put it into perspective,
the first one I delivered to OpenAI was 0.17.
0.17 petaflops. And now we're at 720 petaflops? Imagine how much faster this is going to accelerate OpenAI's efforts, which I already thought to be super fast. Note that the inference speed is 1.44 exaflops, exactly twice as fast as the training speed. Well, that's because NVIDIA has a new floating point format with 4 bits instead of 8 bits called FP4. So half as many bits means twice as much speed.
FP4 effectively doubles the throughput. This is vitally important for inference.
And these racks are the building blocks to support models with trillions of parameters. NVIDIA is putting together what it calls an AI factory, which has about 444 of these racks. Altogether, that is then 30,000 of their new Blackwell GPUs, which brings us to 640 exaflops. I did the math, and it checks out. So how does this compare to the previous generation of Hopper GPUs? Well, Blackwell has 5 times more flops per GPU, so only 1/4 of the GPUs are needed to do the same task, and therefore also only 1/4 of the energy needed. The math didn't fully math here, but in any case, the point is that it still takes the same amount of time to train, 90 days, but now less GPUs are used, so that could go either towards other training tasks or bigger models.
Even larger models. We're going to train it with multimodality data, not just text on the internet, but we're gonna train it on text and images and graphs and charts.
Blackwell joins Hopper in NVIDIA's series of DGX systems, which is their AI solutions for enterprise. So you'll see the term DGX being used around interchangeably. So where does that put us in the grand scheme of things? Well, within 8 years, it's been a 1,000 times growth in accelerated computing. This here is a 5x that's been mentioned. So then Jensen's like, Moore's Law who? Granted, I'm pretty sure Moore's Law meant to hold all other variables the same, and you're kind of cheating a bit with the FP format here. But an optimization is an optimization, and we love to see the growth. And it's looking exponential now, which further and further brings us closer to the reality of AI reaching general intelligence and then super intelligence at exponential rates. Things are about to get even wilder really fast. Inference is also seeing a 30x speedup, thanks to both the larger chip size and the new chip design and additional parallelizations. Also notable is that the Blackwell system comes with a RAS engine.
RAS engine, a reliability engine that does 100% self-test, in-system test of every single gate, every single bit of memory on the Blackwell chip and all the memory that's connected to it. The ability to detect a weak chip or a weak node early, we could retire it and maybe swap in another processor. That ability to keep the utilization of the supercomputer high, especially when you just spent $2 billion building it, is super important.
The decompression engine also allows the data transfer in and out of these GPUs to be 20 times faster.
These computers are so powerful, and there's such a large investment, the last thing we want to do is have them be idle. And so all of these capabilities are intended to keep Blackwell fed and as busy as possible.
It is truly commendable how NVIDIA has not only improved every single aspect of this platform, but also continues to add new features to it. From head to toe, this system is phenomenal. And now, everybody wants a piece of it. NVIDIA is collaborating with so many companies right now in all sorts of different sectors.
In life sciences, healthcare, genomics, transportation, of course, retail, logistics, manufacturing, industrial.
What do you think is going to happen once NVIDIA figures out how every other industry works? Just sit pretty and do nothing? What does every corporation in a capitalist system permitting infinite growth do? Next, we got NIMs. Jensen motivates it by saying that we have all these computer vision models, language models, robotics models, some of them open sourced. But to use them, you gotta run inference. And running inference on these models with trillions of parameters means that you would need GPU hardware and infrastructure. Well, to save you the trouble, you can just use a NIM.
A NIM, it's a pre-trained model. They could be open source, they could be from one of our partners, it could be created by us, like NVIDIA Moment. It is packaged up with all of its dependencies. So CUDA, the right version, cuDNN, the right version, TensorRT, LLM, distributing across the multiple GPUs, Triton inference server, all completely packaged together. And it's connected up with APIs that are simple to use.
But you don't need to speak code with the API. You can speak in prompts to the API. So Jensen calls it an AI API.
An AI API is an interface that you just talk to. And so this is a piece of software in the future that has a really simple API, and that API is called Human.
So we have an AI API for AI models on AI hardware. Gotcha. And a library of these NIMs is available on ai.nvidia.com, offering language generation, image generation, code generation, text to video, digital humans, so much.
Ready to work on your systems, so long as you have NVIDIA GPUs in your data center or in the cloud, this NIMs will work together as a team and do amazing things.
NVIDIA is essentially controlling the marketplace for AI, and it can do so because it controls the hardware needed to enable it. And it doesn't stop there. The power of these conveniently packaged NIMs is the ability to use them together. The example given is a custom healthcare NIM and a digital human NIM.
I'm Rachel, your AI care manager.
She is a digital human NIM, and she's connected, in this case, to Hippocratic AI's large language model for healthcare. She is just super smart about healthcare things, you know? And so after you're done, after my Dwight, my VP of software engineering, talks to the chatbot for bugs database, then you can come over here and talk to Diane.
Y'all, for real, the AI models are already so powerful on their own, and now we get to unite them together just so seamlessly. This is game-changing.
How do we build software in the future? It is unlikely that you'll write it from scratch or write a whole bunch of Python code or anything like that. It is very likely that you assemble a team of AIs. And someday there's going to be one of these chatbots, and these chatbots is going to just be in a NIM.
Jensen knows that you'll want a NIM to be trained on your own data, like proprietary enterprise documentation, so that you can use LLMs for your own specific needs, like a custom GPT.
The enterprise IT industry is sitting on a gold mine. If they could take that gold mine and turn them into copilots, these copilots could help us do things.
NEMO is a tooling and service that helps clients fine-tune their own NIM. They help you curate and process your data like PDFs and spreadsheets and encode it into a vectorized format so that it can be added to a vector database ready for training.
And that AI database, in the future, once you create it, you can talk to it.
Each company can now use its data that it's been collecting for all this time to now create their own chatbot and copilot that is truly intelligent. This is going to increase the productivity and capability of each company by a lot.
AI copilots that are co-designers with our engineers. And so this is the way we did it. So we got ourselves a Llama 2. This is a 70B, and it's packaged up in a NIM. We say, thanks for that answer. It's completely wrong. And then we present to them, this is what a CTL is at NVIDIA. And the CTL, as you can see, CTL stands for Compute Trace Library, which makes sense. And it wrote the program. Isn't that amazing?
Some of the customers that Jensen mentions is
SAP generates 87% of the world's global commerce. Basically, the world runs on SAP. We run on SAP. ServiceNow, they run 85% of the world's Fortune 500 companies run their people and customer service operations on ServiceNow. Cohesity backs up the world's data. They're sitting on a gold mine of data. Hundreds of exabytes of data, over 10,000 companies. Snowflake is a company that stores the world's digital warehouse in the cloud and serves over 3 billion queries a day. Everybody who is building these chatbots and generative AI, when you're ready to run it, you're going to need an AI factory. And nobody is better at building end-to-end systems of very large scale for the enterprise than Dell. And so anybody, any company, every company will need to build AI factories. And it turns out that Michael is here. He's happy to take your order.
This NVIDIA-Dell partnership is so significant that the camera even panned off of Jensen, then onto Michael Dell in the crowd. With all of that, the NIMs and the NEMO and the DGX cloud, NVIDIA is calling itself
an AI Foundry.
And deservingly so. So all of that was AI on a computer. Jensen argues, though, that if we truly want AI to be understanding our world, then we would need the AI to be physically interacting with our world. Hence, physical AI in the form of robots.
Can you give me a high five?
Sure thing. Let's high five.
Can you give us some cool moves?
Sure. Check this out.
This dude does not stop. We keep on going, leaving no stone unturned.
The ChatGPT moment for robotics may be right around the corner. We're going to have human examples in articulation form, and the AIs will watch us, understand what is happening, and try to adapt it for themselves into the context. And because it can generalize with these foundation models, maybe these robots can also perform in the physical world fairly generally.
So for this, NVIDIA has another new chip called the Jetson as part of their AGX platform.
World's first robotics processor. It's designed to be very low power, but it's designed for high-speed sensor processing and AI. And so if you want to run transformers in a car, or you want to run transformers in anything that moves, we have the perfect computer for you. It's called the Jetson.
Omniverse is an AI simulation technology, part of their OVX platform.
We need a simulation engine that represents the world digitally for the robot, so that the robot has a gym to go learn how to be a robot. So that's how the robot knows that as it's learning these articulation capabilities and manipulation capabilities, it's going to adapt properly into the laws of physics. We call that virtual world Omniverse.
There, you can have digital twins, aka like the digital version of your warehouse or your engineering plan. And in there, you can have autonomous agents like NPC humans and the robots that you're trying to train, and AI models that are overseeing everything, getting trained, and interacting with you, the user of the digital twin.
Warehouse, factory, building will be software defined. So you test the software to building the warehouse, the optimization system in the digital twin. What about all the robots? All of those robots you were seeing just now, they're all running their own autonomous robotic stack. And so the way you integrate software in the future, CI/CD in the future, for robotic systems is with digital twins.
But creating a virtual simulation and all of these 3D graphics can be a time-consuming effort. So of course they added AI capabilities to Omniverse to take care of that.
Omniverse into an AI and integrated it with the ability to chat USD. And so that language is rather complex, and so we've taught our Omniverse that language. And so you can speak to it in English, and it would directly generate USD. You could also look for information in this world semantically. And so you could ask it of certain objects or certain conditions or certain scenarios, and it can go and find that scenario for you.
I've worked with USDs myself before, and they are time-consuming and not the easiest format. So this will be a major speed up. And once you have your digital twin and 3D assets, you can experience them on the Apple Vision Pro. That's pretty rad. So altogether, where does that leave us? Well, if you combine the OVX for the simulation, the DGX for the AI training, and then the AVX for the interaction, then you have an end-to-end pipeline for intelligent autonomous systems. And this applies for autonomous vehicles, robotic arms, and humanoid robots. Let's talk about the humanoids some more. Something that we can't gloss over is the fact that NVIDIA already has a foundational model trained for humanoids.
This is NVIDIA Project Groot. A general-purpose foundation model for humanoid robot learning. The Groot model takes multimodal instructions and past interactions as input and produces the next action for the robot to execute. We developed Isaac Lab, a robot learning application to train Groot on Omniverse Isaac Sim. And we scale out with Osmo, a new compute orchestration service that coordinates workflows across DGX systems for training and OVX systems for simulation. With these tools, we can train Groot in physically based simulation and transfer zero shot to the real world.
They're sharing the infrastructure and the tooling with us, but they're already miles ahead. They have fully functional robots that are just getting smarter by the day.
The Groot model will enable a robot to learn from a handful of human demonstrations, so it can help with everyday tasks and emulate human movement just by observing us. This is made possible with NVIDIA's technologies that can understand humans from videos, train models in simulation, and ultimately deploy them directly to physical robots.
Well, that's nice, but I sure hope that they're not teaching it with UFC fight videos. I do a bit of combat sports myself, and I would not want to go up against a robot. I can see the future now. Robots, headsets, digital incarnations. The line between artificial and reality is getting thinner and thinner.
Good luck. I am inevitable.
All right, so that's all of what NVIDIA had in store for us today. The 5 pieces to the new AI revolution. Phew, are you overwhelmed? Because I sure am. NVIDIA's got the AI hardware, the AI software, the AI services, and now the physical AI. They're doing everything end to end and literally expanding the endpoints as they go. Each of these platforms could have been their own individual powerful company, but NVIDIA just had to go for all 3. They are literally 5 steps ahead of us. Make that 5,000. And they're ready to revolutionize every industry. Art, finance, banking, healthcare, you name it. I'll leave you with this. NVIDIA is making its own efforts in the healthcare industry as well. Could it be a little concerning that NVIDIA is involved in healthcare and genomes and also humanoid robots? What do you think?
So that we understand the language of life.
I don't wanna cry.